Astronomers have used the Hubble Space Telescope to forecast a future cosmic pileup, the titanic collision of the Milky Way and the Andromeda Galaxy in about 4 billion years' time. The Andromeda Galaxy, some 2.2 million light-years away, is the closest spiral galaxy to our home, the Milky Way. For around a century, astronomers have known that it's moving towards us, but whether or not the two galaxies would actually collide, or simply fly past each other, remained unclear. Now, a team of astronomers has used the Hubble Space Telescope to shed light on this question by looking at the motion of stars in the Andromeda Galaxy.
Okay, we wanted to figure out how Andromeda was moving through space. So in order to do that, we measured the location of the Andromeda stars relative to the background galaxies. In 2002, they were in one place, and in 2010, they were in a slightly different place. And that allowed us to measure the motion over a period of 8 years.
The motion is actually incredibly subtle and not obvious to the human eye, even when looking at Hubble's sharp images. However, sophisticated image analysis revealed tiny movements that the scientists were able to project into the future. Based on these findings, it is finally possible to show what will happen to the Milky Way over the next 8 billion years. As the galaxies drift closer, and then collide and gradually merge into a single, larger, elliptical galaxy with reddish stars. And yet the solar system should in fact survive this huge crash.
No, the reason we think that our solar system will not be much affected by this collision between the Milky Way and Andromeda is that galaxies are actually mostly empty space. Even though our galaxy, as well as the Andromeda Galaxy, has 100 billion stars in it, they're very far apart. So if two galaxies actually collide with each other, the stars basically pass right between each other. And the chance of two stars directly hitting each other is really, really small. So the likelihood that our solar system will be directly impacted by another star, for example in Andromeda, as we collide with it, is really, really small. Well, if life is still present on Earth when this happens, the changes in the sky will be quite spectacular. Now, they will be very, very slow because the timescales on the scales of galaxies in the universe are very, very long. So you have to think millions of years. But even then, over these timescales of millions of years, we will see big changes. If we wait a few billion years, Andromeda will be huge on the sky. It will be as big as our Milky Way because we'll be very close to it. And then later, when the galaxies merge, the merged remnant of the Milky Way galaxy and Andromeda will look more like an elliptical galaxy, and we will be sitting right in it. So the view of the Milky Way on the night sky will be completely gone, and this band of light will be replaced by a more spheroidal distribution of light.
And so the Sun, born in the Milky Way almost 5 billion years ago, will end its life in a new orbit, as part of a new galaxy.
Now that you've caught up with Hubble, make sure to get the latest from the ground too. The STScI highlights the best of the European Southern Observatory and its powerful telescopes that observe from high in the Chilean Andes, at the Southern Hemisphere's best-known sites for astronomical observations.